Hello students, welcome to the classroom point. In today's session, we shall discuss the chemical bond multiple choice questions. First question is, which follows Octet rule? So here the given compounds are SF6, PCl5, NH3, IF7. So to find out the which follows Octet rule or not, first of all you should know the valency of the central atom. Here the valency of the sulfur is 6, valency of the phosphorus is 5, nitrogen valency is 5 and iodine valency is 7. So just you add valency to the number of the bonds. Here fluorine, chlorine, ammonia, hydrogen and fluorine, they form only single bonds. So here you will have the 6 valency from the sulfur and 6 fluorine atoms, that equals to 12. Here 5 valency from the phosphorus and 5 chlorine atoms are there. So this is equals to 10. Here nitrogen valency is 5. There are 3 hydrogens to 3 bonds, which is equals to 8. And here iodine 7 valency and there are 7 fluorine atoms, which is equals to 14. So the one that is having the 8 electrons around it is called the molecule that follows the Octet rule. Here ammonia is having the 8 electrons around the nitrogen atom, so that option C is correct. Let us solve the question number 2. In question number 2, the crystal lattice of an electrovalent compound is composed of. They said that crystal lattice as well as the electrovalent compound. Electrovalent compound is nothing but the ionic compound. So ionic compounds always will have the oppositely charged ions. Hence option C is correct for 2. Question number 3. Which of the following is most covalent? Actually these are all ionic compounds, but no ionic compound is 100% ionic in nature. Most of the ionic compounds, they show the covalent nature. So here if you take the molecules given ionic compounds, the given ionic compounds are AlF3, AlCl3, AlBr3 and AlI3. So here aluminum in each of these compounds exhibits the +3 oxidation state. So same aluminum ion is present. So that covalent nature now depends on the anion, size of the anion. Larger the size of the anion, more will be the covalent nature. So among this F minus, Cl minus, Br minus and I minus will have the more size, hence it will have the more covalent nature. Now let us solve the question number 4. Among lithium chloride, beryllium chloride, boron chloride, carbon tetrachloride, the covalent bond character follows the order. It is very simple thing that the covalent character depends on the size of the cation or charge of the cation. So I will write here the covalent nature depends on charge of cation. Actually it is directly proportional to the charge of the cation. So more the charge on the cation, more will be the covalent nature. So here carbon oxidation state is +4, boron +3, beryllium +2, lithium +1. Because here the anion is same, in such cases we have to search only on the cation. So CCl4 carbon is having the highest positive charge over the carbon, so that the order follows option C. Now question number 5. Which of the following bonds is most polar? The polarity of any bond depends on the difference in electronegativity. Difference in electronegativity. More the electronegativity difference, more will be the polar nature. Now let us see the electronegative values of the atoms given over here. So we know that oxygen electronegativity value is 3.5 on Pauling scale, whereas fluorine is 4.0, and here phosphorus and hydrogen comprises of the same electronegativity of 2.1, whereas carbon and sulfur having the same electronegativity of the 2.5. So here 4 elements, oxygen has come, fluorine has come, carbon, sulfur, hydrogen, everything has come. Now let us see here oxygen hydrogen bond in option A. Oxygen value is 4.0 and oxygen is 3.5 and hydrogen is, so this is 3.5, hydrogen is 2.1, difference is 1.4. Now let's go to the option B, phosphorus and hydrogen. Since they have the same electronegativity, so here electronegativity value difference is 0. Next, option C, carbon and fluorine. Carbon value is 2.5, whereas fluorine is 4.0. So now let's take the difference value here, 4.0, 2.5, it is 1.5. And next one is D, sulfur and chlorine. Sulfur electronegativity is 2.5 and chlorine electronegativity is not given here. Okay, chlorine electronegativity value is 3.0, so it is 3.0. So when you calculate the difference values here, 3.0, 2.5, and it is only 0.5. So more electronegativity difference, more will be the polar nature of a covalent bond. So if you observe this, option C is correct for this answer. Why? Because here the difference in electronegativity of these two elements is more, but people usually expect oxygen and hydrogen, but this is the correct one. Question number 6 here. Polarizability of halide ions increases in the order. It is simple thing that polarizability is directly proportional to the size of anion. When the size of anion increase, polarizability also increase. So fluorine, chloride, bromide, iodide, size increase from fluoride to the iodide. So option D is correct. Now let us see the question number 7. What is the nature of the bond between boron and oxygen in this molecule? Given molecule is given. This is an adduct compound. So in this compound actually C2H5 taken twice, oxygen BH3 is given. Actually this molecule exists in this particular form. I'll write here. Boron is connected to the 3 hydrogens, and boron is having one empty orbital, and this is the diethyl ether, C2H5 oxygen and C2H5. Oxygen is having the 2 lone pair of electrons. So oxygen donates one of its lone pair of electrons to the empty orbital of the boron, and so that it can develop the coordinate covalent bond. So here they asked about the type of the bond between the only oxygen and boron. So it is a coordinate covalent bond, hence option B is correct. Now let us see question number 8. The compound which contains both covalent and coordinate bond is. You must remember that isocyanide ion is having both of these bonds, because this is the arrow mark represents the coordinate bond and remaining are covalent bonds. But remaining all cases only covalent bonds are present. Hence option A is correct. 9th question. The type of bond present in N2O5 is. So first of all we must know the structure of the N2O5, so that I will write down the structure of this N2O5 so you can understand it clearly. So in this particular compound, these arrow marks represents the coordinate covalent bond, and the single bonds and double bonds all represents the covalent bond. So it is having both covalent as well as the coordinate covalent bond, hence option D is correct. Now let us see the number of covalent and coordinate covalent bonds in pyrosulfuric acid. So I'll write down the pyrosulfuric acid structure here. First of all, pyrosulfuric acid formula is H2S2O7. So in H2S2O7, the structure is oxygen is connected between these two sulfur atoms, and sulfur in turn is connected to the oxygen through arrow marks, or you can represent this as double bond also. Oxygen hydrogen and oxygen hydrogen. So that if you calculate the covalent as well as the coordinate covalent bonds, first of all let us calculate the covalent bonds. This is 1, 2, 3, 4, 5, 6. 6 covalent bonds are there. Coordinate covalent bonds, 4 arrow marks are there, so that they are 4. 6 and 4 is the answer. So option A is correct. Now let us solve the question number 11. Ionic bonds are usually formed by the combination of elements with. So the answer for this is, a cation must have the low ionization potential, and negative ion what we are going to discuss. So that anion must have the high electronegativity or electron affinity. So this is for the cation and this is for the anion. So once the metallic atom or the cation is having the low ionization potential, they can easily lose the electron, so that they can form the cation easily. For example, if you take sodium, if sodium ionization potential is very less, so it can easily lose the electron, so that it can form the Na plus ion and lose the electron. And chlorine electron affinity is more, so that it can easily accept the released electron from the sodium atom, so that it can form the Cl minus N. So as soon as these ions are formed, they can develop an ionic crystal. So that low ionization potential and high electron affinity are the answer for this one. So option B is correct. So now let us see the question number 12. The question is, choose the correct statement. So the given options is, a cation with non-noble gas configuration is more polarizing than the cation with noble gas configuration. So here first of all, even now also we have discussed many times polarizing part has come. Okay, a little bit I'll explain here. What does it mean by polarizing power? What does it mean by polarizability? So according to the Fajans rule, no cation means no ionic compound is 100% ionic in nature. Ionic in nature. They have certain limitations in this sense. So we know that a cation is formed, cation is nothing but the positive charged ion, and anion is nothing but the negative charged ion. When a cation approaches the negative charged anion, so this positive charged ion attracts the electronic cloud present on the anion towards its side. So as a result, the most of the electron density will come between the cation and anion. So when the electron density is present between the two particles or the atoms, then such type of the bonds actually are called as the covalent bonds. So in this case also, the maximum ability of the cation to attract the electrons towards its side is called as the polarizing nature, and the anion is losing electrons to the cation. So the ability of the anion to lose the electrons to the cation is called as the polarizability. I repeat, polarizability is always with the anion. It is the tendency to lose the electron density, and polarizing power is nothing but about it is a tendency of the cation to attract the electrons towards its side. Okay. Here smaller the size of the cation means more positive charge will be with the cation, so that it can attract the more electron density towards its side. And if anion size is less, it cannot lose the electrons. But if anion size is more, see here I am taking the smaller cation and larger anion. So when the larger anion is there, this nucleus cannot hold these electrons more tightly with it. As a result, this particular positive charged ion can easily attract the these particular electrons towards its side. As a result, this anion will lose most electron density towards the cation, and more electrons will come between the cation and anion, so that covalent nature increases. So the question here is, it is about the cation with noble gas configuration is more polarizing than the a cation with non-noble gas configuration is more polarizing than the cation with noble gas configuration. It is true. The reason is, a cation with non-noble gas configuration is unstable, so that it ready to attract the electrons towards its side. But a cation with the noble gas configuration is stable, and it generally do not try to attract the electrons towards its side. So here option A is correct, and I will take one more example to explain this particular content. You just see here. I will take NaCl. Here Na plus Cl minus. Na plus is with the noble gas configuration because of 10 electrons. And if you take the FeCl3, iron is with the +3 oxidation state, which is non-noble gas configuration. So that iron ready to attract more electrons towards its side, so makes more electron density to locate between the positive charged iron and negative charged chloride ion. But in this case, since Na plus ion itself is stable, is not ready to attract more electron density towards its side. So if you compare these two ionic compounds, FeCl3 is more ionic in nature, more covalent in nature than the NaCl. Let us solve the question number 13. Two elements X and Y have following electronic configuration. If you see the Y element electronic configuration, it ends with S2 configuration, whereas Y element electronic configuration ends with the 3p5 configuration. Means this Y element needs one more electron to form a complete orbital with complete electronic configuration. But this X atom needs some more 6 more electrons to get the 4p6 electronic configuration. But instead of that, this X atom will lose these 2 electrons, so that it will get the nearest noble gas electronic configuration, or else completely filled p electronic configuration. So what the X atom will do? X atom will lose 2 electrons, so that it will form X plus 2. Whereas Y needs only 1 electron, so that it will gain 1 electron and forms Y minus 1. So you forget about these charges, just cross the valencies. These numbers you cross it. So you will get the X1, Y2. Means it can be written as XY2 is the formula for the compound that will be formed but with this electronic configuration. So that option A is correct. So let's try to solve the question number 14. An atom of element capital A has 3 electrons in its outer shell and B has 6 electrons in its outermost shell. The formula of the compound formed between these will be. So in this particular question, valency of A is equals to 3 and valency of B is equals to 6. And here we must remember that for any element whose valency is 4 or less than 4, less than or equals to 4, their valency can be taken as the given number only. For example, if there are 2 elements A, B, C, D like this, and A valence is 1, B valence is 2, C valence is 3, D valence is 4, means we have to take these values only, and these elements are able to form only these main number of the bonds till 4. So for any element, the number of the bonds formed by that particular element is equals to its valency, that to up to number 4. And if any element valence is more than 4, in such cases you have to subtract the given value from the 8. So that here B element is able to form 8 minus 6 equals to 2 bonds. So A element is able to form the 3 bonds and B element is able to form the 8 minus 6 is equals to 2 bonds. So just you write down here A3 and here it is B2, cross the valencies, you will get the formula that is of A2 B3. So that option B is correct. So let's try to solve the question number 15. So here the electronegativity of hydrogen and chlorine are 2.1 and 3.0 respectively. The correct statements about the nature of the HCl bond is actually they are asking about the percentage of ionic nature of the bond that present between the hydrogen and chlorine they are asking. So there is a formula to calculate the percentage of ionic character. Percentage of ionic character is equals to 16 into Xa minus Xb plus 3.5 into Xa minus Xb whole square, where Xa is the electronegativity of the element with the highest electronegativity in the given molecule and Xb is the lower electronegativity. So if you take the hydrogen and chlorine, whose electronegativity is more? Chlorine, that is 3.0. So Xa must be 3.0. So you take the higher value first and lower value later. Otherwise you will get the negative values. So that let us try to substitute these values here. It is 3 minus 2.1 plus 3.5 into 3 minus 2.1 whole square. So if you substitute and do the calculation, we get the values approximately 17%. So option A is correct. Let us solve the question number 16 now. The electronegativity of oxygen, fluorine, nitrogen, chlorine and hydrogen are respectively given 3.5, 4.0, 3.0, 3.2 and 2.1. The strongest bond will be bond strength is directly proportional to the difference in electronegativity. Higher the difference in electronegativity, stronger will be the bond formed. So here if you do the difference values, you will get the answer A for this one. Now let us solve the question number 17. In which solvent NaCl has maximum solubility? You must remember that polar compounds are soluble in the polar solvents. And moreover here NaCl dissociates into Na plus and Cl minus ions. So ionic compounds are more soluble in the more polar solvents. In these particular cases, ethyl parts are there. These are all organic parts. So whenever organic parts are there, they are less polar. And H2O is non-organic compound, inorganic compound completely, and it is a more polar compound, more polar solvent. So that NaCl is more soluble in the H2O. Why? Because if you take the H2O molecule, you will get the oxygen, hydrogen, hydrogen. So electronegative difference values are more. Here it is 3.5 and here it is 2.1. But in the case of the only I am taking ethyl alcohol because the rest of the cases are not necessary here. So the molecular structure will be like this. So one side oxygen hydrogen bond is there in ethyl alcohol, but other side oxygen is connected to the carbon, which is of higher electronegativity 2.1. So that when the electronegativity of the element that is connected to the oxygen increases, so difference in electronegativity decrease, so that the polarizing power decrease, so they become the non-polar solvents. So ionic compounds are more polar, more soluble in the polar solvents only, so that NaCl is maximum soluble in the H2O molecules, H2O solvents. So option A is correct. So now let us see the next one. Question number 18. Which has maximum covalent character? We have already discussed a similar question. Here NaCl, SiCl4, AlCl3, MgCl2. All these four compounds are having the chloride as the anion. So that you forget about the chloride. Now consider the remaining one, that is cation. Here Na plus is there, Si plus 4 is there, and aluminum plus 3 is there, magnesium plus 2. Higher the positive charge on the cation, more will be the covalent nature. So option B is correct. 19th. The dipole moment of HBr is 2.6 into 10 power minus 30 centimeters, and the interatomic spacing means interatomic distance is 1.41 angstroms. The percentage of ionic character in HBr is. So first of all, let's try to write down the data. Here observed dipole moment. Observed dipole moment is given as 2.6 into 10 power minus 30 centimeters. and interatomic distance d is given as 1.41 angstroms. So first of all, let us try to see which formula is helpful to calculate the percentage of ionic character. Percentage of ionic character is equals to observed dipole moment divided by theoretical dipole moment into 100. Observed dipole moment value anyhow given there. Theoretical dipole moment value let us try to calculate. So I will take theoretical dipole moment value as mu th. So theoretical dipole moment value can be calculated as q into d. Q is the quantity of the charge in coulombs, d is the distance. Here quantity of the charge is not mentioned, but if you take the HBr molecule, here if you split this molecule, just imagine H plus Br minus. So only one charge is being formed, so that will take the one charge of electron, that is 1.6 into 10 power minus 19 coulombs. That is the quantity of the charge, and the distance you take in the meters, that is 1.41 into 10 power minus 10 meters. So if you multiply these values, we shall get the answer in coulomb meters, that is 2.256 into 10 power minus 29 coulomb meter. This is also coulomb meter. By mistake I pronounced it as a centimeter. So now let us try to substitute this observed dipole moment value and theoretical dipole moment values, that is 2.6 into 10 power minus 10 divided by 2.256 into 10 power minus 29 into 100. So if after solving everything, we will get the answer as 11.5. So option B is correct. Dear students, hope you like this video. Whatever you are expecting, just please do comment in the comment box. Thank you.